Seagrass meadows are moving beyond their identity crisis. The once ugly duckling of the conservation world is now becoming the beautiful swan. The world is now slowly waking up to the power of this group of humble marine superplants as a kind of part of this complex jigsaw of how we fight climate change. The beauty of conserving and planting seagrass to fight climate change is that it doesn't require buying expensive land, and it doesn't displace current farming activity. In fact, it promotes food supply through the creation of essential fish habitat. Just like trees, seagrasses are all different. They have the equivalent of the slow-growing epic redwoods, such as the Posidonias, and they also have the fast-growing equivalent of the pine forests with the Helophilas. When we translate these differences into rates of carbon storage as a means to fight climate change, just like the world's forests, we get lots of pros and cons in different scenarios. Understanding the capacity to translate these different seagrasses into engines of carbon storage comes down to three key elements: opportunity, rate, and scalability. And all these factors are modified by our knowledge gaps in these systems. The Zosteras sit somewhere in the middle of that range from Posidonia to the Helophilas. The opportunity for the Zosteras is that their coverage has been decimated, mostly over the last 100 to 200 years. The recovery of these environments creates that huge opportunity, that opportunity that's needed for restoration in terms of creating new carbon sequestering habitats. There's still a lot of knowledge gaps about the rate and balance of greenhouse gas emissions of the Zosteras, but evidence does indicate it stores somewhere between 0.5 and 1.5 tonnes of carbon per hectare per year, even within restored meadows. These rates are highly comparable, if not a lot better, than other so-called nature-based solutions. Importantly, these rates can be achieved rapidly as a result of restoration, and the associated methane and NOx emissions are comparably also very low. But we do need to more mechanistically understand what drives the net accumulation of organic carbon so that we can improve conservation and restoration to enhance and maximise those rates. Finally, scalability. Can we actually take the restoration of the Zosteras to a whole new level? Well, Professor Bob Orth and his team in VIMS have actually already demonstrated this unequivocally. Seagrass meadows can be restored at sufficient scale to transform the delivery of coastal ecosystem services. Fisheries can be rejuvenated, carbon storage expanded, and biodiversity enhanced. We now need to build on that experiences of scaling seagrass restoration from the US and use some of the great science that's coming out of places such as Sweden, the Netherlands and Australia, and apply it across the temperate seas. At Project Seagrass and Swansea University, we're also using that knowledge and also learning ourselves about how to scale up seagrass restoration. But we need regulators, funders, marine stakeholders to get behind that push to enable seagrass to fulfill its potential to be this beautiful swan of marine conservation. Thank you.